Welcome to the midterm exam review. In this video, we're going to do problems 17 through 31. So let's start with 17. In this one, we're asked to graph it. So what's going to happen is you're going to have these equations where you want to put them in your calculator, but in order to do that, we have to solve for y. So on the first equation, I'm going to go ahead and if I move the y over on the other side, add it over here, and then if I move the 10 on the other side, I will get, or to the left, I will get y equals negative 3x minus 10. So that one was actually really easy to do. Oops. Okay. So let's do, fix my y there. And then let's do the second one. So if I subtract the 2x on the other side, and then divide by negative 2, oops, go to 2y. And then divide by negative 2, get back where I was here. I'll have y equals x. 4 divided by 2 is 2, and a negative makes a positive. Okay. Let's graph the negative 3x minus 10 first. So I'm going to go ahead and put a 0 in for my first equation, because if I do on the first equation, if I put in 0, I get negative 10, which makes it easy to go ahead and just do the slope, which is negative 3 over 1. Well, I know I don't want it to go this way. That's the wrong direction because that just takes me off the graph. So I'm going to go backwards. So I'm going to go up 3 to the left 1. Just make sure that your slope is a negative slope. 1, 2, 3. There's another one. There's another one right there. Okay, so then I can draw that line right there. Okay, now x plus 2 is going to look like this. So I'm going to go, and again, I'm just going to put in a 0. And if I put in 0, I get 2. So 0, 2 is right here. And then up 1 over 1. Well, I know I don't want to go this way really because I want to go cross the line. I want to figure out where, my goal is to get the intersection point, right? So there's my intersection point right there. I just crossed my other equation, okay? So I'm crossing at negative 3, negative 1, okay? And that's our answer for number 17. Okay, so for 18, we're going to go ahead and use elimination because I can see it right here. If I add the 2's, I get 0. And if I add the y's, I get a negative 4y. And if I add the 8's, I get negative 16. Okay, just watch your negatives. If you divide by negative 4, you're going to get a positive 4. Okay, so if y equals positive 4, then I can use any one of the equations. I think I'll use this one because there's no negative in front of the x. So if I go y is negative 4, or excuse me, y is positive 4, but I need that minus. Okay, so then I'm going to add 4 on the other side. And if I add 4, that gives me negative 4. And if I divide by 2, I get a negative 2. So my answer is going to be negative 2, 4. Now, you don't have to use elimination. You can pick whatever method you want to use. So if you like to use matrices, you can do that through the whole test. All right, so let's work the next two problems. There are word problems. These are systems, and we need to figure out what the intersection point would be or what x and y equals. Okay. Now, some people like to use letters for the unknowns in the word problem. So let's do number 19. Okay, so for number 19, she charges $3 and $1.80. Those are your totals, and there's only 2 unknowns. So if there's 2 unknowns, I need 2 equations. And my totals are $3 and $1.80. Okay, so it's 2 eggs and 1 piece of toast for $3. So 2 eggs. Now I don't really like using T, but I'll use like a cursive T. And then 1 egg and 1. Now for all these, I'm going to use the matrix. Okay, we're going to do A inverse B, and I'm going to put 2, 1, 1, 1 in the calculator for A, and my B is going to be 3 and $1.80. Okay, so A inverse B, my answer is going to be so I'm going to get $1.20 and 60 in the calculator. So I'm going to write that as for an egg, for each egg, it's $1.20. I'm going to put a little $sign there. Oop, that didn't look good. We'll just take that off. And for each piece of toast, it is 60 cents. Okay? All right, let's do the next problem. So the length of a rectangle is 3 centimeters more than 3 times the width. Okay? It also tells me that the perimeter, which perimeter is 2L plus 2W, is the formula for perimeter, and that it equals 46. All right. Now, I can do this several different ways. It's totally up to you. You can make this into a system of equations where you use substitution or elimination. How about if we use the matrix again? So we have, actually, no, let's use substitution just in case. Because what if the test has a problem on it where you have to use substitution? Okay, so I know L is 3W plus 3, right? I'm going to switch that really quick here. I'm going to erase this just so that it's a better picture. So I'm going to take the 3W, where this 2L would go, I'm going to take and put in 3W. I just use a different color. Okay, now I'm going to distribute the 2, which is going to give me 6W plus 6 plus 2W equals 46. So now I'm going to solve for W because that's my only variable left. So I have 8W equals, and then I'm going to subtract that. I'm going to go ahead and subtract that 6 over since I can do that now. So that's 40. So 8W equals 40. So W equals 5, right? Okay, now I want to plug 5 back in. So I'm going to go 3 times 5 plus 3 equals 18. So the length is 5. Oh, excuse me, the width is 5 and the length is 18. Okay, just make sure that you watch your units. Okay, and that is your final answer. Okay, let's go on. So for 21, we have to show the intersection for this system of equations. But we're actually looking at inequalities, so really we don't have to find just the intersection point, we have to find the shaded area as well. Okay, so I'm going to go ahead and graph these. Now, I'm going to start by plugging in 0, because 0 will give me my y-intercept. So for the first equation, I'm going to be at 0, 2, and we're going to use pink for the first one. So, okay, and then I'm going to go down 3 over 1. Okay, and there's my first line right there. All right, now for the second one, I'm going to put in 0 again, which gives me -3. So I'm going to start at -3, and then my slope is going to be 2. Okay. Draw that line. All right. Now, the second one is a dashed line. So honestly, it can't be a solution at that intersection point 1, -1. That's not allowed because it's not equal to on the second equation, which is 2x minus 3. The first equation is less than. The second equation is greater than. So the first equation, the first equation is less than, okay? And the second equation is greater than. So I'm going to stop right here because that's actually the intersection point between both of them, okay? The first equation is less than, that was the pink line, and the second equation is greater than, that is the blue line. So that would be my answer. Okay, let's try number 22. Again, I'm going to plug in 0 to get my y-intercept, which is -3. So I'm going to start there, and then we're going to go down 3 over 1. Okay. Okay. And then I'll just draw that line real quick. And then we'll switch to another color, and we'll plug in 0. And that'll give me -2. So now I'm going to start at -2. And I'm going to go up 1 over 4. We'll go the other way as well. Right there. And draw that line. Okay. Now, the first line is supposed to be greater than, and the second line is less than. So I'm going to go to where the first line, which is my pink line, is greater than, and my second line is less than. So I'm going to go right here because that is true for both of those. I'm looking for the section where it's true for both. So I don't have to do a lot of shading or erasing. Okay? All right. Make sure that your lines are solid lines. Notice that this was an equal to and this was an equal to. So make sure that both of them are solid lines, because I'm sure that they will have different options on the test for you to pick, and those are the ones that are going to be tricky. Okay? All right, let's try the next problem. For number 23, we're going to set up the equations first. So I'm looking for the number of unknowns that I have, and a cake costs $5 and a pie costs $7. And they sold 15 of these items and made $91. They want to know how many did they sell. Okay, so I'm going to make the cakes into C, pies are going to be P, and they sold 15 of those. Okay, then I'm also going to, this is the one rule that I make for myself, is that if I'm talking about money, then I should have money with the final total, which is money. Okay, now it is perfectly fine if you use a matrix for this problem. So if I did that, I would do matrix A would be 1, 1, 5, and 7, and matrix B would be 15 and 91. Okay, just remember that when you put in a matrix, you need to do A inverse times B. Okay, and if I do that, I'm going to get So I'm going to get 7 and 8. Okay, and the answer is 7 cakes. Okay, all right, let's try the next one, number 24. So I've got vegetarian and chicken. So I'm going to do, it says they cost $1 and $1.80. They made $98.80 and they sold 70. So let's do V. Let's change that real quick. So let's do V plus C equals 70. Remember, money goes with money. So $1 for the vegetarian, and $1.80 for the chicken equals $98.80. Oops. Okay, I'm going to put that into a matrix. I'm going to use A inverse times B, and let's see what that gives me. The answer is 34, 36, and they want how many wraps were vegetarian, so that's the first one. It's always in order. This one's going to be first, this one's going to be first, this one's going to be second, because this one was first here, and this one was first here. So it's going to be, the answer is going to be 34 wraps, or vegetarian wraps, let's put it that way. All right. Okay, let's try the next one. Okay, so this is a linear programming problem where we use the objective function. So the objective function we're going to do later. So we're going to leave this out here like this, negative 5x plus 4y. That one I want later. The constraints are what I'm going to do now. So I'm going to go x greater than 0. So I'm just going to draw 0 real quick. And then I've got y. This is y equals 0 right here. And then I'm going to do y greater than, or excuse me, less than 3. So I'm going to put that one there. And then the y less than or equal to negative x plus 5. So you're going to start at 5. Okay. You're going to go down 1 over 1. It's going to go like that. All right. So I'm going to draw it down like this. Okay. Now, that means my vertices. I need to find my vertices. So I've got one here, and one there, and one there, and one there, which means my vertices are going to be 0, 0, 0, 3, 2, 3, and 5, 0. Now remember, I take all these points and I plug them into the objective function. So I go c equals negative 5 times 0 plus 4 times 0. Well, that's going to equal 0, right? Now do it again. Negative 5 times, put the 0 in for x, put the 3 in for y. So that's going to give me a 12. Do it again. Negative 5 times 2 plus 4 times 3. Well, that's going to make 12 minus 10, so that's going to be 2. and then c equals -5 times 5. Okay, stop the video if I'm going too fast, because these are really just pretty simple as far as adding them up. Okay, so just check my answers with your answers. All right, so I look at the numbers and I decide, okay, which one's the smallest and which one's the largest. Okay, I've got the smallest one is right here and the largest one is here. So the minimum, or excuse me, yeah, let's do minimum. Minimum is -25 at 5, 0, which looks odd, but you know what? Anything can happen because the objective function is what controls this thing. Okay, so don't think that it's the, smallest point, the lowest point, or the tallest point. Okay, so let's do the maximum. The maximum is 12, and it occurs at 0, 3. Because they may ask you, where does the maximum occur? So you've got to give the location and what the maximum number would be. Okay? All right, let's try the next. Okay, so now we have a couple of matrix problems. So I'm going to use A inverse B, A inverse times B. My matrix A for number 26 is going to be -2. Really be careful with the numbers. Make sure that you're getting all the correct coefficients. If there's nothing in front of the variable, then you got to use 1. If there's no variable at all, you have to use 0. Okay, so there's matrix A. Let me just double check that I got them all right. -2, 2, -3. 8, 1, -3, and -2, 1, 4. Okay, and then B is going to be 5, 10, and 7. If you get a weird number that doesn't match, it's probably because one of those was not correct in the calculator. Watch your negatives. That's one of the most important things. Okay, so if I do A inverse B, the answer is going to be 1, 5, 1 is our answer. And it may be in this format, 1, 5, 1. All right? Okay, let's do it again. So for 27, really, you just take 27, put it in your calculator. Okay? Make sure you use the inverse button. That's the button that looks like x to the -1. Okay? And the answer is going to be -5, -17, 2, and 7. Okay? All right. What is the solution of the matrix equation? This is the same as doing A inverse B. It just looks a little bit different. Okay? So I'm going to go ahead and put those matrices in, and I'm going to do A inverse B. Now this is your A because you're solving for x. So A is the one that you want to put on the other side, and imagine you're dividing it. So basically dividing is the same as inversing it. The reason why we inverse is because we can't simply just divide a matrix. It'll cause those dimension mismatch errors. Okay, so I'm going to put that in my calculator, and the answer is, okay, so we've got 88, 59, 37, and 24, and that's our final answer. All right, next problem. For number 29, it just says write the system as a matrix equation. So a matrix equation has matrix A, and we're using x, y, z for our variables that we want to solve. And then we have the answer on the other side. Okay, so write it like this as the matrix equation. Okay, that's our times there. And I'm going to put the 2, 3, and 5 in here. Now, the reason why I did that is because I want to concentrate on the left-hand side. They really made it tricky, which if you don't notice it, you will fall into the trick. But notice that some of the x's are missing, some of the z's are missing, things like that. If a variable is missing, you have to put in 0 for it. So the first row is 0, 4, and 9 for that first equation. So that's the one I'm talking about right there. Okay. The next row, oops, lost my 9. Okay. The next row is going to be 4, 3, and since there's no z, I'm going to do a 0. The next row, 3x minus 6z, that's going to be a 3, a 0 for the y, and a negative 6 for the z. And that's your answer for number 29. All right, now we can go ahead and let's just continue doing a matrix for 30, which is a 1, 6, 1, 5 for matrix A. Matrix B would be 4 and 1. You can choose to do substitution or elimination if you want to as well. So if I do A inverse times B, my answer is going to be negative 14 and 3, which also I'm going to write it like this because this is the proper way to write the point for the intersection point, which is probably what they're going to use on the test. Okay, again, I'm going to use matrix for the next problem here, which is our last problem. So we've got negative 5, 3, negative 2. So I'm not writing it as a matrix equation. I'm going to go ahead and do the A inverse times B here. So this is going to be my B, so that I can just go ahead and write the answer for you right here. So we've got negative 1, negative 1, negative 5. Okay, this is my x, y, z. And then the last one is negative 2, negative 1, 4, and then the other matrix on for the B. Oh, whoops. Okay, yes, I noticed what I did. That's okay. I went into matrix equation mode. This needs to be matrix B. Apologize for that. Okay, so this is 4, negative 21. See what happens when I try to skip a step? All right, so if I put that in the calculator, I'm going to get 1, 5, 3, and I'm going to write it as a point so that I can use the proper format. All right, so that's it for this video. Please let me know if you have any questions, and thank you for watching.